concrete and pre-stressing part. There will be myself, my colleague Milos, who's our product specialist for concrete and pre-stressing, and of course Arvydas. And let's start with a short video about the concrete. Arvydas, please.
This is David, a structural engineer. Every day he analyzes and designs concrete structures. He must cope with challenges of today's construction industry. The whole process is becoming faster, pressure on cost effectiveness is increasing, and there is zero tolerance for errors. That is why StatiCa Concrete was created. Its goal is to provide complete, general and accurate software for engineers who want to understand 100% of what happens inside a structure and its elements. StatiCa Concrete is used by engineers for design and assessment of members in building structures, beams, columns, frames, sections and other details. Main features include dimensioning of sections, design of reinforcement, assessment according to standards and generation of report and bill of materials. Results are clear and immediately available on the screen. All the assumptions used in calculations are displayed. Analysis, design and assessment fully comply with Eurocode and provide a guide to the complicated provisions of this standard. StatiCa Concrete works as a standalone application for complete design and analysis of members in concrete structures. Its BIM interface ensures smooth data transfer from other programs. StatiCa is used by engineers all around the world. Try it yourself. Calculate yesterday's estimates.
It's fine. Okay, good afternoon everyone. My name is Milos Kekeliak. I'm from IDRS company, as well as Juraj Šabatka, and I'm hoping to give you an overview of the StatiCa concrete and pre-stressing modules. So I will start this presentation to describe the most important benefits of using the software. I will describe the main features of the software, and I will start with the main characteristic. So StatiCa concrete and pre-stressing modules, and generally the StatiCa is can be used for design of members, cross sections, and details. And it should be mentioned that StatiCa is a complementary software to the other bigger finite element analysis software packages like RFM or AxisVM or CI Engineer. So it means that the StatiCa can be used for detailed and comprehensive assessment of structural members of pre-stressed or just reinforced. The range of use of application or the concrete and pre-stressing modules. So I will start with the concrete. It can be used for structural design of members for residential buildings or shopping malls or civil structures, and as well for bridges. In case of residential buildings, it can be used for design of prefabricated beams, cast in place slabs, beams, columns. In the case of bridges or bridge structures and industrial structures, it can be used for structural design of bridge piers, columns, and non-pre-stressed elements. In case of liquid retaining and containment structures, it's a group of industrial buildings. We can design this kind of structure. There is an implemented Eurocode for these kind of structures. For both groups, StatiCa provides very detailed and comprehensive member and sectional design, and fast and optimized design of reinforcement. So it's the RCS module, or called the Reinforced Cross-Section module. In case of StatiCa pre-stressing, this module we can use for design of civil and industrial structures, and the second group is formed by bridge structures. This is similar. We can design prefabricated beams, precast pre-stressed beams. Another group is like hollow core slabs, and we can design as well beams and design strips of post-tension slabs. That is quite frequent nowadays. In case of bridge structures, we can design and analyze the bridge piers, columns, and pre-stressed elements of bridge structures, or bridges cast in place or cast in situ into false work. Very important group of structures are the continuous beams with composite slabs. I will show range of application by following slides. We can design tapered beams like this with any kind of variation of cross-section, three-dimensional beam structures like this. They can change their direction in horizontal and vertical directions. Another group, as I mentioned, on the left picture, we can see the roof girder that can be reinforced, only reinforced or pre-stressed. On the right side, we can see the hollow core slab. So such structures can be used for prefabrication factories or prefab factories. As well, we can design or check the structure that are cast in situ and subsequently post-tangent, like beams and design strips, or strips of post-tangent slabs or ripped slabs. Here's the example of post-tangent slab that was modeled in the software Axis VM, and subsequently the model or the design strip with shallow beam was exported into StatiCa beam module for pre-stressing, and in this module pre-stressing tendon was designed and analyzed and checked. Subsequently, the data can be sent back to the software, the 3D modeling software like Axis VM or RFM. This is an example of a design of bridge piers or pre-stressed or non-pre-stressed elements. This is the example of a bridge cast in situ into false work. We can design such structures or such kind of bridges that are just reinforced, or they can be pre-stressed by tendons. This kind of structures is composed of two main composites, and it can be reinforced or pre-stressed beam, and subsequently the structure is made monolithic by casting of composite slab. Such kind of structure we can find or can be used for bridges as well for garages or residential buildings. There is a picture in the bottom of this slide where can we see the floor system with permanent shuttering floor system. So there are precast pretangent girders, and in a further construction stage there is a cast concrete slab, so the structure is monolithic. One of the most important goals of the development team in StatiCa there is to make the software simple. I will demonstrate it on the following wizard. Structural engineer using the StatiCa concrete or pre-stressing as well as the other modules can use the very simple wizard to input the geometry of the structure, load of structure, construction stages of the structure, and can input a quite complicated structure by a very simple wizard. Wizard provides to structural engineer very well or totally well-known terms that are well known for structural engineers. So the input is quite easy and clear. I can show the example of the 3D problem, where is a bridge structure that has a curved shape, and to input a tendon, pre-stressing tendon, into such structure can be quite difficult. So this problem is solved in StatiCa beam pre-stressing module by uncoiling the 3D plane of a tendon into two-dimensional plane or in a plane, and the structural engineer can input this 3D geometry or the geometry of three-dimensional tendon as a two-dimensional problem, so as a plane problem. Subsequently, what is more comfortable? Subsequently, the geometry is exported back to the 3D 3D environment and is calculated. Here is the example where a 3D tendon is presented as a two-dimensional space, and there is an example of stress losses. Another goal in process of development is to provide to structural engineer the software that provides clear white box results. So the results that can be easily checked or controlled. In the slides, I hope it can be better seen. In the right side, on the bottom, there is a planar visualization of a beam. It's scaled to be better, to better for better view. And there, up on this picture, we can see the equivalent load that is caused by pre-stressing. What means that the structural engineer in process of the tendon of the pre-stressing can see the active role of pre-stressing in a specific section. Here are presented the results for particular section. It's a T section that is pre-stressed. So structural engineer can receive very detailed results. On the right side we can see the strain and stresses in a particular part of the cross section. So we can see there a parabolic shape of concrete stresses, then the linear distribution of stresses in non-pre-stressed reinforcement, and that orange color or mark that's there's present the stresses in the tendons. It's on the plastic branch. These results can be viewed or visualized in 3D. And as well, structural engineer can assess the resultant forces in cross section. So resultant of compression force in concrete, in compressed concrete, in compressed reinforcement, and as well in tangent part of cross section where is a resultant of force in a tendon and non-pre-stressed reinforcement. As well, we can check each fiber of cross section. Now there is collect on the top right corner of a T section, that orange square, and we can see the actual stage of concrete in that point. So we can see the stresses and corresponding strain in that fiber. The same action can be done for tendons, press stressing tendons, that is now is collected or selected at the bottom one on the left side, and as well we can see the actual stress strain relation that is of this tendon that is on the plastic branch. StatiCa provides high quality of European standards implementation, the software, and by the StatiCa software, this example, the structural engineer can calculate nonlinear deflection caused by cracks along the beam. So in the second picture from the top, there can be seen the variation of stiffness due to the cracks. As well, we can calculate the long-term and short-term deflections that are presented in the third picture, and as well there are the capabilities or the functionality of a software that can structural engineer use and to enable the reduction and redistribution of internal forces. So the design can be more economic. One of the most distinctive features of StatiCa software is that all structural elements are assessed or checked according to Eurocode, and not only particular stage of their lifetime, of the life cycle, but during whole life cycle. So there we can see the structure on the left side that can be composed of cross-section that are shown on the right side. It's a composite type of structure. And StatiCa provides the check during the whole life cycle. So during the introducing of pre-stression, then in a construction yard, during the transport of element, at the stage of temporary supports at the construction site, as well in the end of life cycle. as well, the structural engineer can add his own service stages for this structure or any kind of structure. In terms of the bridge design, using the idea StatiCa, it should be mentioned that there are introduced load groups for bridges, based on which automatic generation of bridge load combinations are performed. Idea StatiCa provides two main standards. It's a Eurocode and Swiss code, SIA. There can be checked two kinds of limit states: ultimate limit state and serviceability limit state. Idea StatiCa provides the check not only for flexure, shear, and torsion as a partially, but as well the interaction of internal forces. So a structural engineer can check the interaction of flexure, shear, and torsion at the same time, or acting together. As well, there is a check of fatigue or shear in composite joint. For serviceability limit states, there are checks like stress limitation, a decompression condition, crack width, and brittle failure. According to European standard, there is possibility to design liquid retaining and containment structures. It's very easy. Input in the RCS module where structural engineer defines the types of structure, of such structure, and the program automatically calculates the depth zone and provides the result of crack width and if the crack appear or not. European or strut and tie model, according to Eurocode, is used in this detailing tool called a corbel, where the designer can design and assess and reinforce such kind of detail, corbel and brackets. The export to the XF can be done, and it can be done the export of wall reinforcement cage. As I told, there are two main standards now implemented in Idea StatiCa: European standard and Swiss code. For a European standard, there are many of national annexes, and of course we are open to implement any other. Economic design of the Idea StatiCa. I will tell about a few features of the software. It's optimization of angle theta. Angle theta means the angle of compressed diagonal or the strut. Eurocode, the design of shear and torsion is solved or presented as there is implemented the variable angle strut model, and structural engineer can decide the value of angle theta. So it's up to structural engineer this value, to decide this value, and this feature automatically calculates the optimum value of angle theta, and it improves the economy of design, so it leads to optimum use of all materials. So compressed strut of concrete, or concrete in compression, shear reinforcement, and longitudinal reinforcement. As well, the RCS model, or the model of implementing concrete module, provides fast and precise design according to Eurocode. So there is automatic design of reinforcement that satisfy the ultimate limit state condition and as well the serviceability limit state condition. They are written or presented in this slide, and what leads to reuse of weight of reinforcement as of shear reinforcement as well for longitudinal reinforcement. And this design works with not necessary areas but with real bars, so it improves the economy as well. It improves the link up to drawings, so it's not imaginary the areas. Safe design. This feature of software is probably most important for our customers, and it's the main reason why they buy our software. To sum all the information to make a summary of the information I presented, the ITS StatiCa RCS provides complete and comprehensive assessment. So the check is very detailed, transparent assumptions and white box results, and a perfect guide to Eurocode. So all the reports provided by the ITS StatiCa for concrete or pre-stressing are presented in the form that a structural engineer can really simply identify the clause from Eurocode based on which the check is done. Every check that is done in ITS StatiCa is presented as with the reference to code, Eurocode clause. So now I will present a few examples of a BIM or building information model and a workflow from other softwares. Here, this is the starting interface of ITS StatiCa, and a user can run this interface and import the structural model into ITS StatiCa BIM interface and make very detailed assessment of structural members or of the wall model. Here's the example of a residential house. It's a quite luxury house that was assessed by this software, and it is 50 meter long, 25 meter wide, and because of a big span of a structure, there was necessary to introduce pre-stressing into the slab. The structural model was done or was created in RFM, and in the RFM there is implemented the plugin created by ITS StatiCa for tendon design, and the results of calculation were exported or can be run directly from RFM, and the design of pre-stressing tendon was done in the IDEA tendon environment by this plugin. Here are the pictures from the realization of this structure, some kind of reinforcement from a construction place, and here is a kind of reference. Here is an example of a pre-stressed girder. Such girder can be as well designed as a non-pre-stressed, but due to the big span, it's 25 meters. It was designed as pre-stressed girder. It was done by a German company. Design was performed in an IDEA beam module, pre-stressing module, and there was done the design of tendons. Here are presented the internal forces calculated for this beam. Here are the cross sections. The left cross section is at the support. The cross section presented in the middle, it's probably in the third of span, and the cross section on the right side, it's in the mid span of a beam. Here are the results that were presented in previous slides. We can see the compressed part of a cross section, and on the right side we can see the strains and stresses as well. Any other checks and results can be presented. They are just a few chosen for this presentation. Okay, so thank you for your attention, and I will ask my
Before we
colleague.
jump to the examples, I would like to share one story of a customer. It was 2 years ago. It's a Swiss precast company, and they started with us by buying one license. They started calculating standard beams, and gradually they started to use the software more creatively, basically asking us for help every other day. So it turned into a more consultancy service. We were helping with their projects, and 1 year ago they said, okay, we want to develop a tailor-made solver for our pre-stressed offering. It should implement our biggest pain, this fire design. So do that for us. So we said okay, and that's the top layer of what we can do for the companies. We set aside a bunch of our guys and developed a tailor-made solution for that precast company. Actually, today, you saw at the video our CTO, Jaroslav Navratil, he's our main pre-stress guy, and he's not here today because he's finalizing preparations for tests of this new solver for the fire design resistance. There will be a big test in Germany, a real life test when there will be basically burning big concrete columns and beams. So next time, hopefully, we will not overlap, and Jaroslav will come again with us. And we have the honor to not just have him in the company, but also he's been very active in teaching the pre-stress community in Central Europe and other countries in the world. We have a couple of his books here, so after the workshop, we would like to get a good read on the pre-stress concrete. Please come talk to us. We have 5 of the books, and we can give it to you. And with that, let's jump to the examples.
Kaip kolega paminėjo, tai turim 5 knygas įtempto gelžbetonio. Kadangi niekas neprojektuoja, nežinau, ar jums jų reikia. Bet, jeigu rimtai kažkas projektuoja pakankamai gerą literatūrą, jeigu palyginu su Marčiukaičio paskutiniu leidiniu, tai ten truputį yra daugiau ką paskaityti. Tai gerai, mes jums parodysim 3 tokius trumpus pavyzdžius. Pirmas pavyzdys, tai tiesiog tikrinsim skerspjūvį. Antras pavyzdys truputį sudėtingesnis, jau įtempto gelžbetonio pavyzdys. Ir sekantis yra, tiesiog parodysim integraciją iš Lubal ar Femo. Integruojam, pasirenkam elementus ir atliekam tą pačią analizę. Aš truputį grįšiu pirminę skaidrę, kad turėčiau užduotį. Pasileidžiu vėl idėją StatiCa, įsirenku konkret sritį. Kaip minėjau, verta paminėti, kaip ir minėjo kolegos, tai yra tų pačių ne tik skerspjūvio, bet pačios sijos, kolonos, 2D rėmo. Toliau yra plokščių, įtempto, neįtempto.
Gal vaizdelę nereiktų matyti?
O, atsiprašau. Vienam tik įdomu, visi kiti miega. Supratau. Skaidrės bent jau matėt. Skaidrių nekartosiu, pasileidžiu idėją StatiCa, kaip minėjau. Yra keli moduliai, tai yra beam, kolona, 2D rėmas, plokštė ir minėtas StatiCa metodu atliekamas gelžbės skaičiavimas. Dar verta paminėti, kad idėja StatiCa su Vokiečių baigtinių elementų universitetu 17 metais žada išleisti gelžbetonio mazgų skaičiavimo programą StatiCa metodu. Kaip minėjo, pakankamai paprasti nustatymai, viską palieku pagal nutylėjimą, spaudžiu OK. Toliau grupuoju elementus, galiu 1, 2, 3, dviatramis, daugiatramis ir taip toliau. Šiuo atveju man pakanka tiesiog dviatramio. Pasirenku skerspjūvį, atsidarau skerspjūvių bazę. Yra pakankamai nemažai įvairiausių skerspjūvių, jie taip pat gali būti laisvai modifikuojami. Pasirenku, tarkim, vieną iš šitų. Reikia man užduoties, kad galėčiau. Apkrovoms aš panaudosiu Excelį, bet vis tiek skerspjūvį man reiktų nusirašyti. Tai yra plotis metras, aukštis 500. Jo, ačiū. Visi jau žiūri. Gerai, flank thickness HF 120 palikim. Web thickness 200. Gerai. Čia 30, jeigu neklystu. Gerai. Turime skerspjūvį. Toliau pereikim prie apkrovų. Kaip ir minėjau prieš tai, gali būti importuotos apkrovos iš įvairių programų, tiek Airframe, tiek Axis, tiek Skia. Toliau susirasiu Excelį. Kažkur aš jį čia turėjau. Tiesiog Ctrl+C, Ctrl+V, turiu apkrovas, pereinam prie armavimo. Armavimas yra pakankamai daug įvairiausių template'ų, jie pakankamai lengvai konfigūruojasi, bet taip pat galima ir rankiniu būdu įvairiausius tipus modifikuoti. Šiuo atveju aš pasirenku Wizard armavimo tokiam elementui. Automatiškai pagal skerspjūvį yra sukurti tie, pavadinkim, nustatymų langai. Tai pažiūrėkim, ką mes čia turėtumėm pridėti. 8 dvyliktukai viršuj, 2 šešioliktukai apačioj. 8. Okay. Here lower bars. Nu, tiek to. Pažiūrėkim, palikim kažką. Skersinę turbūt praleidau. Skersinę padarykim. It's 200, yes?
It can be. You can comment it, that is better.
Okay. Toliau mes galim pereiti prie skaičiavimo. Ir matom, kad skersinė jeigu pas mus nelaiko elementas, tai kaip ir kolega rodė prieš tai, mes galim atlikti, vadinkim, tai yra strat optimization, teta. Tiesiog čia pasirenkam, paspaudžiam ir matom, kad mūsų kampas teta, jeigu jūs matot.
You can use Control plus Wheel.
Matom, yra 33,7, tai reiškia, kad į skaičiavimus įstraukta išilginė armatūra ir matom mūsų skerspjūvius jo šiuo atveju laiko. Aišku, mes galim iš to gauti begalę informacijos, tai pradėjus nuo interaction schemos, momento ašinės jėgos, įvairiausių, toliau skersinės informacijos. Šiuo atveju pas mus nėra sukimo, bet skerspjūvis redaguotas atsižvelgiant į Eurokodo reikalavimus. Toliau įvairiausi įtempiai, armatūrai, betonė, begalė įvairiausių nustatymų. Toliau čia mes kalbėjome apie saugos ribinį būvį, jeigu kalbant apie tinkamumo ribinį būvį, taip pat yra plyšiai ir taip toliau. Jeigu reikalinga detalesnė analizė, tai jeigu mes kalbam apie seismiką ir standumą, tai tiesiog per settingus aktyvuojame, periname prie Advanced Analysis lango ir čia mes matom informaciją, įtempius taškuose. Taip pat mes, aišku, nepaminėjau, galima ir atkreipti dėmesį, grįžtam atgal, kad atliekama analizė ne kaip baigtinių elementų programuose, kai yra nagrinėjamas sritis, čia yra nagrinėjamas konkrečiai strypas ir skerspjūvis. Toliau M-kapo diagramą, jeigu mes kalbam apie seismiką ir taip toliau. Ir aišku, reportas. Standartinis, detalus ir taip toliau. Pakankamai aiškus. Ir pakankamai paprastas. Tai kaip matot, pakankamai aišku ir paprasta naudotis. Tiesiog reikia Eurokodą žinoti, belieka. Tai principe čia toks pirmas skerspjūvio pavyzdys, kadangi galim pereiti prie antro, tai manau čia man pagelbės kolega, nes įtemptas gelžbetonis yra pakankamai specifinės sritis, apie ją galima kalbėti labai daug. Aš truputį pakomentuosiu, kad...
Okay, so... Maybe you can swap places.
Okay.
Okay, so I will briefly describe the environment of StatiCa beam module. I will show basic functions and features of the software to provide you some kind of overview of work in this software, and it's on the desktop. This. Okay. Okay. So I opened a project of composite structure. Such kind of structure can be a bridge structure, or it can be as well some kind of prefabricated beams of garages or shopping malls and any other structure. Or it can be as well some kind of floor system where the floors are prefabricated and subsequently made monolithic. It's kind of structure that I presented in my presentation. So I will describe such structure. I have to say in the beginning, this structure was inputted by probably 3 dialog or 4 dialogues window of Wizard. So the input of such structure was very, very easy. I can demonstrate it later. So in the project data, we can set the main data of the project, like standard, the kind of bridge, or if it is not a bridge, it doesn't need to be a bridge structure, design working life, and these data are then considered in design and check. So I will go to as well. I will just describe. Here is the cross section. We can modify cross sections. Materials, they are according in accordance with the Eurocode. Members structure is divided into particular beam members. We can define haunches and variation of cross sections I will go to construction stages that I mentioned in my presentation. The most distinctive feature of StatiCa software is, in terms of design of concrete, is that a structure is assessed during their entire lifetime. So here is the structure, and I will list very fast the list of construction stages. A structure is composed of 3 spans or 3 types of beams, or 3 beams. The first one is on the right side, and here I clicked, see, the stage of casting of this beam, then a stage of transferring of pre-stressing, then a storage yard, then the casting of the second beam, because they are produced with a 10 days delay, and the transfer of pre-stressing the second one, storage yard, again for the third, casting, pre-stressing, storage yard. And these stages that I presented right now, there are stages only till the stage of prefabrication, transportation on the construction stage. Okay? So in the stage when they are moved to the construction site, the structure is placed on position, and there are only beams. In subsequent or in further stage, there is a stage of casting of composite slab. You can see that the green elements represents the casting of composite slab and the diaphragms about the supports. Subsequently, this structure can be post-tangent, so there are left places for tendons, and this structure is post-tangent. But it doesn't mean that it must be done. Of course, structural engineer can decide, can change all the parameters during from the production of the structure till the end of working lifetime of the structure or particular member. Here is the stage, final stage, end of design working life. It was for 50 years, so it's the number of in days. I will go to combinations. I will go to load cases. So load cases that are inputted, by the wizard, are automatically generated with the corresponding loads, and we can check the permanent load groups, variable load groups. Here are presented the bridge load groups because it was checked or selected as a bridge. The structure is selected as a bridge, so this application automatically generates combinations for bridges. I'm going to combinations. Here I click on edit, and we can check all the combinations, but the combinations are separated in particular construction stage. So we can see here the stage of transferring pre-stressing. There is a few load cases for this combination, and I can go to stage casting of composite slab, and here we can see more of the load cases, because there are rheological load cases and additional loads applied on the structure. Here can we see the combination in the end of design working life. So there is a full list of loads in these combinations. So the input of such structure is quite easy, even it doesn't seem probably for you at this moment. There is a calculation. I will run calculation. It's a TDA analysis, time-dependent analysis. If would be somebody interested in this analysis, we can provide that book that Juraj mentioned. There is a description of this methodology, and it's a nonlinear analysis using the finite element method, considering the creep as well. The nonlinear creep can be applied or enabled for this calculation. And the structure is calculated for each construction stage. So It's quite a big structure. Now I will show you some results. So we can check the reaction for a particular stage. Yeah, so I will put the final stage so we can see this. I can show deformation of such structure as well. We can see deformation for a particular stage of structure. They are in the storage yard for elements. This is presented for 2 elements, but I can choose all. I can choose, for example, quasi and end of design working life. So this is the deflection in the end of design working life for quasi-permanent combination. We can check the internal forces as well for a particular construction stage. So now is the stage when the only first beam is prefabricated. Then I click on the second, and this is the time when all 3 beams are produced and pre-stressed. As well, I can go to the final stage when we can see the internal forces in the beams. We can check the normal forces, shear forces, or bending moments. As well, we can use the software for reinforcement. It's quite comfortable. We can click here and use a reinforcement template. It's a template that will Arvydas show in following example, but it's quite easy. As well, we can use the software for design of tendon. So we can design reinforcement non-pre-stressed and as well pre-stressed reinforcement. Here are the reports. This is the standard. So structural engineer can produce standard and detailed report of this structure. It's quite a big structure and many sections, so even the standard report is consuming some time. So this is structural report for structure. It's a standard report. It's not detailed. It can be more detailed because it's a quite big structure and it includes many of construction stages. For detailed check, it can be used the RCS module. It's a module for reinforced cross sections, and we can run it by this icon, detailed. And now the program runs the module RCS.
Just a little bit closer. Okay.
And this is the RCS module that Arvydas already showed you. So we can click all, and this function checks and calculates all cross sections. I'm not sure if this example is done that all be satisfactory, but I hope no. There are some conditions according to Eurocode that are not satisfied. So we can click here. So it's very easy for structural engineer to identify the problem in structure, even in this complicated. I click on this line where is a red cross. I will go here. I list it. This is this one. I select it, and I go to checks. And I know that it's a stress limitation, so I go to stress limitation. And if I zoom, I can see there is a problem in initial stress in the tendon. Yeah, but it looks fine. It's 0.1 difference, so it's fine. It's not 1%. But of course, it can be modified. This design can be modified, but it's very easy to for structural engineer to identify the problem. As Arvydas already showed you, we can see the results for any of section and for any of construction stage. This is the stage when the slab is not even cast here, so we can go to different stage. For example, I will go to final to see this, and now this kind of section is analyzed, and we can see all the checks that have been presented: the capacity with the interaction diagram, shear, as well torsion, as well interaction of internal forces, and as well the checks for serviceability limit states. So from my side, I think that it's all. So the colleague will show you the last example.
Okay, thank you, Milos. Aš manau, dabar jau daugelis jau išmokot įtemptą gelžbetonį projektuoti ir stadijų sužinojot, kaip tai daroma. Aš dabar trumpai parodysiu, jeigu mes kalbam apie integraciją iš kitų baigtinių elementų programų, tai kaip minėjom anksčiau, tai yra Axis, Midas, Global, Skija ir robotas. To grįšiu prie skaidrės. Turim tokį modelį globalį, aš jo globalį neatidarinėsiu, jeigu po to kažkas kils kažkokių klausimų, galima tą procesą parodyti klausimų sesijos metu. Tai aš iš karto atsidarysiu paruoštą failą. Tiesiog. Matom, atsidaro langas truputį kitoks negu šiandien jūs matėt. Tai mes pamatysim pilną skaičiuojamą modelį. Aišku, mes galim įsijungti solidus. Matom dvišlaitis sijas, apačia truputį yra su nuolydžiu. Pats integravimo įrankis sugrupuoja elementus. Jis supranta, kad kolonos yra kolonos. Ten, kažkur čia nuėjau, atsiprašau. Kad galiniai rėmo rygeliai yra viena grupė ir trečia grupė, kas man šiam pavyzdį aktualu, tai yra mūsų laikantis dvišlaičiai rygeliai. Jeigu mes pereitumėm prie apkrovų, čia pasirinkim grupės, trečią grupę ir išjunkim, pasidarykim permatom. Tai įražos visos perėjo iš baigtinių elementų programos, šinės, jėgos, skersinės ir taip toliau. Toliau, ką mes galim padaryti, mes galime atkreipti dėmesį, kad programa dėl, kaip kolega minėjo prezentacijoje, tą skerspjūvį ištiesino dėl tikslesnio, patogesnio armavimo įvertinimo. Šiuo atveju programa taip pat automatiškai suskaidė mano skerspjūvį į 3 dalis, tai yra tamsiai mėlyna zona, žalia zona, šviesiai mėlyna zona, jos armuojasi panašių principų. Aš iš anksto pasiruošiau tom zonom armavimą. Čia paspaudžiu. Aš pasirinku savo template'us, turiu pasiruošęs tokius template'us, tarkim. Pakartot turiu, ne tą skerspjūvį pasirinkau. Kas čia dabar ta vis... Oi, atsiprašau. Yeah, okay, we'll leave. Go to here. And for A. Paliekam. Tiesiog nepaskaičiau ir spaudau vis naują sukurti. Čia B greitai. Čia matom iš karto automatiškai, kadangi zonos suskirstytos, tai jis ir parinkus šitam priskiria ir trečiam. Ir mūsų C skerspjūvis. Na ir turim importuotą dvišlaitę sėją, suarmuotą, apkrovas atėjo iš baigtinių elementų programos, belieka tik atlikt skaičiavimus. Kadangi atlieka netiesinę analizę, atlieka iteracijų skaičių, tai tas šiek tiek užtrunka. Toliau mes galim, kaip ir minėjo kolega prieš tai, pereiti prie rezultatų. Tinkamumo ribinis būvis, stiprumo ribinis būvis, įvairiausi įtempiai, tai yra long term deflection, short term, intermediate, linear, non-linear, limit. Visą informaciją mes galim pamatyti, tik tiesiog gal išjungiam skerspjūvio formą, pasididinam ir taip toliau. Ta patį mes galim perkelt bet suformuoti ataskaitą. Taip pat, kadangi mes esam importavimo modelį, tai taip pat yra skiltis, yra steel design, connection design ir taip toliau. Tai tiek trumpai apie patį importavimą. Mes grįšime į patį modelį.
Even for this, we can make a detailed analysis. So one analysis model.
Kaip ir rodė prieš tai kolega, tai mes taip pat galim atlikti ir detalę analizę, kur matėm prieš tai. Mano pirmam pavyzdį mes perėjom prie elementų detalios analizės su visomis įražų, iteration diagramomis ir taip toliau. Ką mes parodėm dviejose prieš tai pavyzdžiuose. Tai tiek.